let's look at number 27. It says in a recent study, the Centers for Disease Control and Prevention reported that blood pressures are normally distributed with a mean of 85, 80.5, and standard deviation 9.9. Okay, A. What proportion of women have blood pressures lower than 70? Yeah, here's 70. Lower than would be shaded this way. So we'll do normal CDF, and I won't plug all these in the calculator, but I'll do setup. Low value over here is negative E99, comma, our high value, which is 70, comma, our mean, comma, our standard deviation. Okay, so I do second VARS, normal CDF. I can down arrow to it and press enter on it, or press 2. The negative, second comma, 99, comma, 70, comma, 80.5, comma, 9.9. And they round it to 4 decimal places, 0.1444. Okay, B. What proportion of women, proportion same as percentage, have blood pressures between 75 and 90? So I got 75 and 90, and it's saying in between. So that'll be normal CDF again. Our low value, which is the far left, 75, comma, and then our high value, which is 90. This is based upon shaded region, comma, our mean, comma, our standard deviation, and then whatever that gives you. Okay, C. Blood pressure greater than 90 is hypertension. What proportion of women have hypertension? So greater than 90. So here's 90. Greater than would be shaded to the right. So this is E99 over here. So we do normal CDF, 90, comma, E99, comma, our mean, comma, our standard deviation. Now D. Is it unusual for women to have blood pressure lower than 65? Well, they're asking us to find a probability. Lower than 65 would be this way. So clear over here is negative E99. So we got normal CDF, negative E99, comma, 65, comma, 80.5, comma, 9.9. And let me actually plug this one in. You have to have the probability to actually answer the question. So do second VARS, choose normal CDF, negative E99, comma, 65, comma, 80.5, comma, 9.9, 65, okay, enter. And we got 0.0587. Now this is, it says, is it unusual? If it's less than 5%, it'd be unusual. This is greater than 5%, so the answer here would be no. Let's see, 29C. It says, let's see, centers for blah, blah, blah. Mean is still 80.5, so I guess it's the same setup, isn't it? Standard deviation is 9, or 9.9. I'm kind of tired this morning. It says find a 67th percentile. So what they're telling you is they're telling you that the area to the left is 0.67. Now by default, if the area, this is 67%, this will be 33%. Not that we need that. And we're trying to find this value. So we're going to use INV norm. And INV norm is always based upon the area to the left, which would be your 0.67, comma our mean, comma our standard deviation. And I'm going to check this. 0.67, comma 80.5, comma 9.9. And we get 84, they round it to 2 decimal places. So it'd be 84.86. Number 33C. 33C. Okay. Guess I'll start a new page. Okay, so let's see. U.S. Wildlife report that the trout, the mean is 481. So I'm kind of skimming it, looking for the pieces of information that I know I need, with a standard deviation of 41. And then I'm looking at C, which says find the first quartile. Well, Q25 is equivalent, Q25, try that again. First quartile, Q1 is equivalent to our 25th percentile. So what we're looking for is the area to the left will be 0.25, and we're trying to find this value. So we're going to use INV norm, and then we'll put in the area to the left, which is 0.25, comma our mean, comma our standard deviation. So do second vars, normal CDF, 0.25, comma 481, comma 41, enter. 1. What did I type in wrong? Oh, normal CDF. Okay, I'll wake up here eventually. Second vars, INV norm. 0.25, comma 481, comma 41, enter. Looks more reasonable. Okay, so 453, assuming 2 decimal places. Let me look. Yeah, 2 decimal places. 453.35. Okay. D. Size limit should be put on trout that are caught. What should the size limit be so that 15% of 6-year-old trout have lengths shorter than the limit? Okay, I have to think about this one. Okay, this is referring to lengths, and 15% have lengths shorter. Okay, if I'm reading that right, they're telling us that 15% goes over here. And if that's 15%, of course, this is 85%. We don't need that, but sometimes I read these problems wrong myself, and it actually wants 15% over here. So I'll put 0.15 and then our mean and our standard deviation. Okay, so I'll do second vars, INV norm, 0.15, comma, 481, comma, 41. And they round to 2 decimal places, looks like. So let's do 438.51. Okay, number 41C. 41C. Okay, lifetime, blah, 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 blah. Mean is 40. Standard deviation is 5. C, find the first quartile. Well, again, they're asking for Q1, which is equivalent to P25. So the area to the left will be, again, 0.25. So we'll do INV norm, 0.25, comma our mean, comma our standard deviation. And I won't actually plug that one in. D. Tire company wants to guarantee its tires will last at least a certain number of miles. What number of miles in thousands should the company guarantee so that only 2% of the tires violate the guarantee? If I'm reading that right, 2% over here. And then this would be 98%. Don't need that, but this is the value we're trying to find. Now this one I'll type in because I'm kind of tired this morning and I want to make sure I read the problem correctly. So 40 and 5. Okay. Second vars INV norm 0.02 comma 40 comma 5 enter. Two decimal places, 41D, 29.73. Yep. The reason why I said I wasn't sure if since it's kind of early, I wanted to read it, is sometimes they'll say, should the company guarantee so only 2% of the tires violate the guarantee? They could word that differently and say that we want 98% of the tires to succeed, or not, the opposite. So they could ask the opposite. So you have to be kind of careful when you're reading it, whether they're giving you the 2% or whether they're giving you this value over here.